So we have nested if statements. And what this is simply saying is that you have, let me check this. Yeah, okay. So you have an if and else, and you can put inside that if and else another if and else. So I would say, if you go to, if you are hungry, go to cafeteria. Now, when you get to the cafeteria, I can ask if there is food, you buy the food, in the sense that the second if will only work if the first one is true. So the way it works, if I can just try to annotate something here. So I can start by one if and then an else. So I'm saying that if you are hungry, go to cafeteria. Now, so when you get to cafeteria, so if this is true, you start executing all what is here. If it is not true, then you skip all that and then you come to execute the else. And so you have the if. So let me type this here so that it's easier to see. So you have an if here and then an else here. Okay. So if you are hungry, okay, go to cafeteria. Else, go to the stadium. So what it means is that the system will start executing this. And then if this is true, then of course this will run. If it is not true, that will run. But while this is true and this is running, you can have another if. So we're saying that, okay, if you get to the cafeteria, no, okay, this is true, go to cafeteria. You get to cafeteria, say if there is food, then you can buy the food, else you can come back. So there is another if and else inside there. So there's if here, and there's else here. So we can see that else. So we can see that there's an if and else inside this if and else. So this if and else is, starting, and then you have another one in. So this is what we call nesting. So if you are hungry, go to cafeteria. You get to cafeteria. If there is food, buy food. Now, even if this is true, you can have another if. I can still go on to say, okay, if you are, if there is food, that is true. If there is no food, then you have to do something else. So here, if there is food in the cafeteria, else do this. I can have another if inside. You say that if there is money, or if you have money, so I have go to cafeteria, there is food, and there is money. So before you can, so it means you can have another if and else inside, this if and else, also inside this if and else. And so we call this nesting. So, and you can do it as many times as you want, or as the computer will process it in a matter of seconds. So you can have if and else inside if and else, and so on and so on. So we call this nesting. So as you are writing your programs, it's possible that you probably come across something that will require so many ifs and else. And in fact, all the applications we use every day have series of these, And so like I always use the ATM as an example, there's always if this is your PIN is matching with what is in the database, okay, display this, else display that. You enter the amount. If the amount is less than what is in the account, do this, else do that, and so on. So it keeps going on and on. Sometimes it will even tell you the printer is not working. So do we still want to go ahead? So you say, if you want to go ahead, do this, else do that, and so on. So there are a whole lot of if and else statements in programming, of course, and it helps the computer to make decisions, or the program to make decisions. So we call this nesting, or nested if and else. So the example that we will now look at is this one. So now here is the case. I've asked the person to type in the number of hours you've worked. Now, because I've just left it open, what happens if the person types a totally unacceptable amount? Because here, assuming somebody comes and say, okay, I worked for 100 hours. Now, we know that you can't have 100 hours work in a week. So, but the person has typed 100 hours, but the program goes ahead to calculate the person's overtime pay. You see, because it's just only one condition. If the hours worked is greater than 40, do this. So no matter what the hours are, somebody comes to say, okay, I worked for 1,000 hours, or 1,000 hours in the week, and then the program calculates the person's overtime pay, 7,200. So in the week, your normal work, you get only 220. That overtime pay is that doesn't make sense. So what it means is that we need to have something that will check to be sure that people don't enter above a certain number. So for example, we want to say that, okay, we can pay you overtime, but there's no way you can work overtime more than 20 hours. So we're going to say that you should never have overtime more than 20 hours. So what it means is that if you enter and it is more than 20 hours, I mean 60 hours now, because your regular pay is 40 hours and your overtime and your regular rate, your regular number of hours is 40. Your overtime shouldn't exceed 20. So your total hours worked should not exceed 60. So we're saying that if your hours worked is greater than 40, whilst you are processing the overtime pay, check to see whether the overtime pay is above a certain amount or the hours worked is greater than 60. In that case, you are going to have an if, else inside the if and else. So I'm going to do this. So I've calculated the person's regular pay. I've calculated overtime pay. Okay, you can have the total pay there. It's not necessary, but I'm now going to check and say, no, if the overtime pay, so I can put here if. Now, so the policy here is that I wouldn't, okay, overtime. Oh, let me separate this so that now normally the computer doesn't care, but we the people reading should always. So I can have this. So overtime pay. So I'm saying that is greater than, let's say greater than 150 cedis. So I can do this. What we're saying here is this should be in, oh, I'm putting it at the wrong place. Okay. Control X here. Yeah. Put in your parentheses. Yeah, okay, so here. So I've calculated overtime pay, but then there's a policy that says that no matter the amount of overtime you do, we're not going to pay you more than 150 cedis, or we're not going to allow you to enter more than 60 hours or 20 hours overtime. So there are two ways of going about it. So either your hours worked should not be above 60, or when I calculate your overtime pay, it should not be above 150 cedis. Because your regular pay is 220 cedis. So there's no way we can pay you overtime. No, that is almost up to your regular pay. So what we are saying is that when you calculate the overtime pay and then you realize that it's above 60, you can tell the person something. No, this is not, we can say this is not allowed. Or in some cases, it was put there, you are being dishonest. Okay. So I'll just put here. Okay, so I'll just say overtime pay is, okay, what is in the program is that you are being dishonest in the sense that the person has put in more than the number of hours that is expected of the person. So when you calculate the overtime pay, it goes above 150 cedis. And so you can have this if, else. So else, yeah. Okay, or else. So open this. So we realize that, okay, we can now calculate. So what it means is this if, and then that's the else, the corresponding else. So I'm not trying to display all of this. Yeah, okay. So there's, okay, what is happening here? Oh, there's another. Okay, I'll get to that. Yeah. So we are saying that if this is true, do all this. If it is not true, come and do this. But in the process of doing this, now you come across another if. So if that is true, you do this or you do that. So what we are doing here now is that there's an if and else inside another if and else. There's an error here. Let me see what is that. Insert this to complete statement. Else, if this, else that. It says as you insert else. Let me see. I'm missing something. Okay. Okay. All right. So, okay. So we have the, yeah. So here, once this is true, I'm going to begin executing this. And in the process, no, once this is true, so the person has done overtime. So I'm going to calculate their overtime pay. But after I've calculated their overtime pay, I realize that, something is not right. And so I have another if and else in there. So this is where the nesting comes. So if I now run this, what we are going to get is that the person doesn't do overtime. The person works 35 hours. Then you can just tell the person, this is your pay. That's your overtime. That you have no overtime pay because it is this else that is running. The whole of this is not true. So it skips all this, and then it comes to work on the else. But if with the person enters the normal, what we expect of overtime, so you've done 45 hours, and then that case will give you your pay, will give you overtime pay. And so you have your, everything is fine. But if somebody decides to be dishonest and says, I worked for 200 hours, now 200 hours, then what happens is that it is a second if or the nested if that is going to run. So it will tell the person that you are being dishonest because you've calculated the overtime pay and it's above 150. We'll come to look at what to call and or and other things. So this is nesting. In fact, within the else too, we can have another if and else nested in there. So nesting is just when we come to talk of loops, you also see nesting within loops and so on and so on. So if and else can be nested or can be within an if and else, and you can even be there and then you can have another if and else and so on and so on. So this is what we call nesting, and it, of course, it makes the programming very easy because now you can make several decisions based on whether something is true or not. And when it's true, you start executing. But when you are executing it, you can decide to check something again. If it is true, you do that, and so on and so on. So we have things like that. So if you take the slides, you can try to run this and then see. So so to make even things a bit more easier, or to make the code simpler, we have what we call logical operators in addition to our if and else. So just like I talked about the nesting, if else, inside another if else, and so on. Rather than doing that, we have other two, in fact, there are four other operators that we can use. There's the and then there's the or. So we have and, that is when you see this two ampersand, we call this ampersand signs there, or the two straight lines. So one is and then the other is or. And it's just like our normal English. So I can say, if you are hungry and you have money, okay, go to cafeteria. So rather than saying, if you are hungry, go to cafeteria, then when you get to cafeteria, if you have money, buy food. Yeah. So what we, if anybody has a comment or question, you can just raise your hand. So I'll allow you in. Okay. So rather than doing if and else nested inside another if and else, I can just use the end. So I can say, if you are hungry and you have money, but I can even add another end. It doesn't matter. But no, we can just say, if you have money, if you are hungry and you have money, okay, go to cafeteria and buy food. It's the same as saying, if you have money, go to cafeteria. Then you get to cafeteria. If you have, if you are hungry, go to cafeteria. And when you get to cafeteria, if you have money, buy food. So rather than doing the two ifs or nesting one if inside the other, I can just say, if you are hungry and you have money, then go to cafeteria. I can also say, if you are hungry or you are thirsty, then do something. So the and and the or, they mean two different things, in the sense that this, if you are using the and, the first should be true, the second should also be true. So the two must be true before whatever you have in there will work. So in case one is not true, then it's not going to run, because I can say, if you are hungry and you have money. Now, if you are hungry but you don't have money, of course you can't go to the cafeteria, because you need money to go and buy the food. And then if you are not hungry and you have money, of course there's no point going to the cafeteria as well, because you don't have money. I mean, you are not hungry, so there's no point going there. But for it to work, then both have to be true. And so when you use the and operator, then both conditions have to be evaluated to be true. And so, and this is how you put it. You put parentheses, the first one, you see that now is double. So this is taking care of the whole thing, because when you write the if statement, you have to put it in parentheses. And within it, you are having another set of Boolean expressions. So both have to be evaluated to be true. With the or statement, only one needs to be true for it to work. And because it's or. So if I say, if you are hungry or you are thirsty, come or go to cafeteria. Now, so one can be true and one can be false. It will still work, because I said or. So if you are hungry or you are thirsty. Of course, if they are both false, then that will not work, because, or that code will not run, because none of them is true. So let me end this. So if we look at the program again that I was discussing. So here we have, I'll just run this so that we'll see what is happening. If hours worked is greater than 60, or overtime pay is greater than this. So in this case, what we are saying is that the person has typed in some number of hours. Now, there's a policy that says that you should never do more than 20 hours overtime in addition to your regular time. So in this case, when you type in whatever number of hours you worked, it should never be above 60. And so we have, put that in. If it is greater than 60, then we are going to tell you that, this is not acceptable, or you are being dishonest. Also, there's a policy that no matter the overtime you've done, even if if not up to 60, but if we calculate your overtime pay and it's greater than 150, we are still not going to pay you, because what's happening is that the policy is that yes, we are not going to pay more than 150 cedis over time. And so we are using an or. So if we are saying that if your hours work is greater than 60, that is true, then the whole of this will not work. But if it's even greater than 60 and we calculate your overtime pay and it's greater than 150, it's still not going to work. We're still not going to pay you. So in that case, we'll tell you, when we come to talk of loops, we'll look at how you can, go back, the loop and start again and tell the person, please re-enter another value. But for now, what we're going to do is that we're just going to say that, okay, so rather than saying if hours worked and then come down to say if overtime pay is this, we can put the two together with as one line. So this simplifies the code. And now we also have if, else, if. Okay, so here, rather than saying else, do this, and then if, so that you have if and else inside a statement, inside another if and else, we just have else if. So this if here, comes to this else, and then also comes to that else. So now what's happening is that if this is not true, if both of these are not true, this is because this is or, then this will skip, and then it will come to this. If this if one is not true, this will skip, and then it will come to that. So what we're saying here is that we're using and. So and means both must be true. So in this case, your hours worked should be greater than 40 for you to qualify for overtime pay, and your overtime pay should be less than or equal to 150 before you can qualify for, or before we agree to pay you. We're saying that if it is above 150, we are not going to pay you. So this is where the and the or comes in. So it comes in to sort of simplify the code. And so if I can just copy this, so let me end this, so that I can copy this. Yeah, oh, it has come all the way back to, where are we? Not switch. Yeah, so here, let me just copy this regular pay, okay, the whole thing. So that I'll bring it to, copy this, I'll bring it to the IDE. So we're going to just replace all this. So let me move this down. We have all this already. So hours worked. Which one did I copy? I copied from, yeah, regular pay, enter hours worked. Okay. Okay, so enter hours worked. All right, so the whole of this. So let me just paste this. Okay, so here, regular pay. So this is regular rate. Regular. So the regular rate is what we are paying. Oh, let me clean this thing. Okay. So here we are. So we are saying that if your hours worked, okay. So here we've calculated. Okay. All right. So here we've calculated. Once you enter your hours worked, we can take this and then calculate your regular pay, and then we can also calculate your overtime pay. Okay. So your overtime pay is hours worked minus 40 multiplied by your overtime rate. So this is done irrespective of whether your, let me bring this down. When you, yeah. All right. So now here, this is what we have. This is where we have the statement. If hours worked is more than 60, or your overtime pay is more than 150, notice that there's no semicolon there. So when you do the if, you don't put my charger. Yeah, you don't put a semicolon there because you end the statement, but it's not supposed to end. So we're saying that when we see that, we say you are being dishonest, or we cannot pay you that amount. Else if this and that, then we'll print out your regular pay, and then else, so this should end. I should close this, and then I say else. Oh, I've closed it already. Oh, okay. It's closed here. So normally these things now, at least the IDE will prompt you that, there's something that is not, but when we're doing these things manually, what is happening is that you would have, yeah, okay, else. You realize that regular pay is this. I think I have something that is missing. Okay. Let me see. So let me close this. So if this, else if, so this, I need to close this if, where is it? Yeah. And then else that, and it says what? Oh, okay. It's regular rates. Okay, good. So, all right, let me minimize this. Okay, so here, all right, so now if we run this, so it's the same thing like the nested if and else that we're doing. So rather than having the nested if and else, we use the and then the or operators. So hours worked. Right. So if you do 34, what's happening is that you get your normal pay. You don't have overtime pay. So that is accepted. You do 45, you get your normal pay and your overtime pay. I took out the total pay one, but that's fine. So that's acceptable because your regular pay, your overtime pay is not above 150. And so, and your hours is not above 60. So you get your regular pay and overtime pay. Now you enter 61, for example. So remember we say greater than 60. So you enter 61, then it will tell you that no, you are being dishonest because what's happening is that one of these is true. So here, hours worked is greater than 60. It doesn't even evaluate this because this is all. So all means the moment one is true, then it goes on to print this. If this is not true, but then this is true, then it will still print this. So in this case, so if I enter, if I run, and like somebody entered 100 hours, so 100, what's happening is that it will still print this. In fact, now they are even both true because the hours worked is greater than 60, and then overtime pay is also greater than 150. So this takes care of the nested if and else. So in situations where you are going to encounter so many if else, and so on, we use the and and the or operators. And these ones, like I said, it simplifies the code so that you can easily, and bear in mind, we are saying that for the or, one of the conditions have to be true, and for the and, both have to be true for the code to run, or for the code that is within this to be executed or to run. So those operators tend to simplify the code a lot. But they're not the only ones. There are two others. They're sort of called the not operator. So apart from the and the or, there's the not. And anytime you see exclamation mark in Java, it's a not, or it negates the whatever the Boolean expression was. So if it was going to be true, when you put the exclamation mark before the condition, then it turns it to be false, or it becomes the opposite. And so remember when we're doing the operators, that is numeric operators, we have plus, minus, and then equal to. And no, this was the comparison operators. Greater than, less than, equal to, and then not equal to. So the not equal to, so here, let me just quickly. So you have greater than, but I don't need to do the greater than equal to. So you have greater than, you have less than, you have, now equal to in Java is the double equal sign. So if you want to use a comparison, or if you want to compare things to say, is this equal to that? Then you use a double equal sign. If you use a single equal sign, that's an assignment operator. So once you see the exclamation mark, it means it's not equal to. So if I say 10 is equal to 10, of course, or maybe 5 plus 5 is equal to 10, then that is true. If I say 5 plus 5 is not equal to 10, then of course that is false, because the exclamation mark makes it the opposite, or turns it negative. So what we're seeing here, the example here is that you have, if I have my age is 20, and then your age is 15, and then I say my age is greater than your age. Look at that alone, that is true, because 20 is greater than 15. So, it's greater than 10. So that should be true. But because I put the not in here, now it comes before, not after. If you put it after this, you're going to get an error. So it comes before, and so not now makes it false. So I was going to say that you are hungry, true or false. If it is true, then if I say you are not hungry, then of course that becomes true too, because I mean that becomes false now, because they're not, it's just like in English anyway. So they're not makes it the opposite. So anytime, so here your age is greater than 20, it's not true, because your age is 15. 15 is not greater than 20, but the not makes it true, because it turns it the other way. The other operator, which you would be coming across, but maybe we will not use it that much, is what we call the exclusive OR. Exclusive, this one works with two Boolean expressions. And so you have an expression, and then rather than the and or the or, we put this exclusive OR here. And this one, what we are saying is that you evaluate this, you evaluate that. Now, if this is true, and this is also true, then the entire thing is false. The exclusive OR operator is saying that one must be true and one must be false for the whole thing to be true. So if they are both false, the whole thing is false. If they are both true, the whole thing is true. And so we say it's exclusive OR, in the sense that exclusively we want one to be false and one to be true. So if you take my age, for example, let me clean this so that it doesn't mess up the whole place. So if you take my age, for example, my age is 20, your age is 15. If I say my age is greater than 10, that is true, because 20 is greater than 10. Your age is also greater than 10. That's also true, because 15 is greater than 10. But the entire thing is false, because we are using exclusive OR. And it's false because one is true, the other is also true. So in that case, the exclusive becomes false. My age is greater than 10. That is true. Your age, which is 15, is greater than 20. That is false. So because one is true and the other is false, then the whole thing becomes true. So we're saying that it becomes true if and only if they have different Boolean values, in the sense that one has to be true and one has to be false. Now, for now, you'll be having issues or think of how you will apply this anywhere, but we'll be seeing it subsequently. So there's a simple code here that demonstrates all these things. Let me go next. Yeah, so here, if you look at this code, we have this class logical operators. So no, normally the import should come before. This is wrong. So here, if you are importing the scanner class, it must come before your class. You can't import it into your class, and the import starts with a lowercase. So when you see this import java.util.scanner, then it tells us that you are going to take input from a user. And so we have imported the scanner class. And like we were saying the last time, the scanner class is not by default in your program, unlike the system class. There are other classes you'll be coming across. In fact, there's something like the math class. Let me see whether you can, you can do something like, let's see, I can say, let me just declare another variable. So let's say double, let me see whether this will work. Double square roots. Okay, you can do something like this: math dot square root. I'm going to skill RT. Let me see. Square roots. I haven't done this. Yeah. Okay. So now, if you do this, oh no, the math class. Where is it? Maybe you have to import it. Another illegal. Okay. There's something I have to. Okay. I'll come to when we come to talk of the math class. You can use the math class and then do a whole lot of calculations, square root, and then all the other things that you can do in normal arithmetic. I was trying to see whether I can demonstrate it. Whether you have to import it, because in this case you have either to import it or it is there by default, so that when you create your Java class, then you don't necessarily have to directly import the math class, and you can use it just like we're using the system class. But when it comes to the scanner class, we have to import it. Yeah, somebody's hand is up. Is it Redeemer? Yeah.
So the math.square, it is math.square, then you bring the parentheses. It's not, the square is not inside the
It's not in the
parentheses.
parentheses. Oh, I see what you mean. Okay, that's fine. Yeah, so you are doing a square root of something. Yeah, but what I wanted to demonstrate is, let me see. Okay, so so I've said double. I want to just find out whether square roots. Okay, so maths. Yeah, okay. Dot this sqrt, and then this comes in parentheses. So you want to, okay, it says overtime pay, but let me just say 45. So in this case, what we are doing is that we are trying to, okay, yeah, you don't get any error, because now in the math class, you haven't actually imported it, but it is there. So in this case, I can equally print out square roots. So here, maybe I can say, let me just, what, you are being dishonest. Okay. I wanted to see whether I can print out the square roots. Let's add, okay. Let's see what, no. Before I do that, let me just copy one. So that in case this is true, let's print out the square root. Okay, square root. Okay. So you see that, yeah, system that print square root. Okay. All right, so let me run this. So if our hours worked is within what we have, 45. Okay. Hours worked for regular pay is this. Oh, which one is it working on? Hours worked. Okay, it's not greater than 60. Okay. So run again. Hours worked greater than 60. Overtime pay. Oh, I want the first one to run. So okay, let me enter the 100 and see. Okay. Okay. So it turns out, so this is actually the square root of 45. We've assigned it to a variable square root. And so we can use the class without necessarily importing it. So once you just write math, so this tells you that the math class is already in Java, and then all you need to do is use the method, to evaluate, and then this is what we call a parameter. So it takes in, so this method takes in parameters. We'll come to talk of methods eventually. So yeah, so this is how, so you can see that some classes, you can use them in your program, others you cannot, because without the import, the moment you comment this out, it's going to alert you that, you cannot create an object when you have not imported the class. So going forward, eventually you'll be seeing some of the classes that you need to import and those that you don't necessarily have to import. In fact, so if you now also do things are already put in there, if I'm not using square roots, but I just say math.py. Now, so what this is that math, this, now if I run this, oh, errors exist where I have an error. Oh, commented out the, okay. So if you say enter hours worked and I enter my 100, okay, 199. So this is pi. So it has simply printed out because I said, where is it? Square root is math. So this tells you that all these things are already defined within Java. So Once you just say math.pi, no, we know what pi is, 3.14. That's indefinite. You can continue going so many decimal places. Okay, so these are, there's something raised to the power this. You can even do quadratic equations. In fact, you can a whole lot. Now, Java allows you to do very complicated, mathematics and other things, because all those classes and methods are already inbuilt. So you just call it by typing a single line of code and you get it. Okay, so here we want to run this and see, but before we do that, let's see what is happening here. We have a statement here that says enter an integer. So we have printed out enter an integer. And now, so this int, the number is a variable, and then we have input.nextInt. We should have, yeah, so we created our object input, and now we do input.nextInt. So it means whatever has been entered is now assigned to number. And now we're using the modulus operator this time. Modulus is saying that if I divide the number by 2 and the remainder, remainder, so modulus is not the answer, but it's the remainder. So I'm saying that if I divide by 2 and the remainder is equal to 0, so this is our equal to in Java. So it's not going to be a single equal to sign. So this is going to be evaluated. Now, if this is true, because I'm using AND, so I'm going to have this also evaluated. And so if both are true, I'm going to print out that the number is divisible by 2 and by 3, in the sense that you can divide the number by 2, you wouldn't get a remainder. You can divide it by 3, you will not get a remainder. Okay, so but if both of these are not true, or if one is false, then this will not run. It will come down to the next if. Now these are not nested. They just if this, then go to this and so on. So you come down to this, and then it evaluates if this is true, or, so this time is or that is true. So in this case, you only need one to be true for it to work. So the top one, both have to be true. This one has to be true. And we're going to say the number is divisible by 2 or by 3, in the sense that, you can divide the number by 2 and there will be a remainder, and there will be no remainder. You can divide by 3, there will be a remainder, that's fine, no problem. But at least because I'm using or, it will still run. So now if I'm using the exclusive or here, what's happening is that I'm going to evaluate this and also evaluate that. If they are both true, this is not going to run. If they're both false, this is also not going to run. But one has to be true and one has to be false. So we're going to say that, okay, the number you've entered, you can divide it by 2 or you can divide it by 3, but not both, in the sense that both cannot be true. If both is true, then the whole of this becomes false, and then this will not run. And then we have the exclusive here. So if you divide the number by 2 and the remainder is not equal to 0, you divide by 3, the remainder is not equal to 0, then we're saying that the number is not divisible by 2 or 3. So in that case, so in this case, you can easily demonstrate how these things work. Let me quickly clean this so that I can yeah. So we have and or, then we have exclusive or, and then the not. So okay, I don't need to close this. Let me just go to the ID. This one is, yeah, okay. I think I have it. Where is it? Variable, no, logical operators. Yeah, okay, so they are here. So let me clear this first. Yeah, so that's what we have. So we do our regular inputs, and then input.nextInt. So we now assign a value to the number, and this is the process I just went through. So we do AND, and then we do OR, then we do the exclusive OR, which is just that, and then we do the not equal to. So this is actually using both, so not equal to and then not equal to and that. So So we can run this and then see what happens. So it simply says enter an integer. Now, of course, when it says enter an integer, if you decide to enter point something something, it doesn't make sense in the sense that the system is expecting an integer. So it specifically says enter an integer. Right? Because if you put in a double, this one, but what we have, this method is waiting or is going to work with an integer. If you want double, then you have to say next double. So this will not work if you don't really enter an integer. So if you enter an integer, I put an integer there, 67. Okay, let me start with, say, let's say 60. And then you enter. Then it says 60 is divisible by 2 and 3. And then it's divisible by 2 or 3. So the first two are true because when you divide 60 by 2, you get 0. So this is true. And this is also true. So this will run. Now it comes here. One of them is true anyway, so it will also run. But the rest, it's not going to execute in the sense that, you know, it's saying that 60 divided by 2, the remainder is 0. Divided by 3, the remainder is also 0. So both of these are true. And because both of these are true, the exclusive OR is false. So it doesn't run. So it doesn't print this. And of course, it doesn't print the last one too. But if you enter an odd number, so let's enter a simple number like 7. So 7 here. Then it looks like everything else is not so. You divide 7 by 2, there's a remainder 1. You divide by 3, there's also a remainder. No, the same thing here. So all this is not true. This is also not true. This is not true as well, because what's happening is that you are using the exclusive. This 7 divided by 2, the remainder is not 0, so that's not true. Divided by 3, the remainder is not 0. So both of them are false. And because both of them are false, this doesn't run. So it only comes to run the last one, which is, this is true, because if you divide 7 by 2, you get 3, remainder 1. And 1 is not equal to 0. So this is true. In that case, this one too is true. And so for that matter, it will say it is not divisible by 2 or 3. And so depending on what you put in, you can put a number that is divisible by 2. So 14, for example, 14 is divisible by 2, but not by 3. So in that case, the first one is not true because you divide 14 by 2, that's 7, remainder 0. So this is true. But now you divide by 3, and then you have 12, you have remainder 2. So 2 is not equal to 0. So this, because one of them is false, the entire thing here is false, it doesn't work. No, so it only works when you have situations depending on the operators you are using. So we call this the AND, the OR, the NOT, and then the exclusive operators. And it's mostly used for comparison. When you want to compare some Boolean things, and you say this and that, and so on. So they just to tell you that apart from the if and else and nesting the if and else, we can have the OR and then the AND operators. There's a last one which we call the switch. So the switch statement, that one has some 4 keywords that we are using. Now the switch statement, what it does is that, you know, you have a specific value, or maybe, yeah, whatever, yeah, it can be a value or anything, and you are going to compare it with several others. So all the others we are comparing with, we call them cases. So I can say, okay, I have a whole class, and then I want somebody who is 10 years old, for example, in the class, or maybe let's say at the university level, let's say 20. So I'm looking for a 20-year-old person. So I can say switch, and I put 20 in there. So the 20 that I've put in, or I've assigned to the switch, not assigned per se, but with the switch, what I'm asking the program to do is that it should go through the various cases. So it's now going to go through the list of the students one by one. So each of them is a case. And wherever it matches. So if you now come to get one where the case matches with what is in the switch, then whatever statement is in there, we are going to execute it. And so what the switch does is that it gives you the opportunity to have several. So rather than doing if and else, and so on, or if, no, you can have the switch and then the case, in which case you have, so there are 4 keywords, like I said. The switch starts the structure and is followed by a test expression. So once you do switch, it's more or less evaluates what is inside the switch. We'll look at the code shortly. And then followed by case. So the cases are the various options. So case 1, case 2, case 3, and so on. And then the break. So once you get a case that matches what is in the switch, you execute the code and then you break, or you end the program. In the sense that, I mean, once I already find a match, I can have 100 students. I'm looking for one who is 20 years. Once I go 1, 2, 3, and the 4th one, I get the match, then I break and then go execute or exit that and then go on to the next, in the sense that you don't necessarily have to go through all the cases again because you've got your match. And then the default is the one that you execute if all the cases, none of them matches what you are looking for. Then you put a code that is the default. So you can see that these are keywords in Java. And so let's look at some simple code here. So again, what we want to do is that this is a scenario where maybe an instructor or a teacher have marked students and I've given them marks, out of 100. So 1 to 100. But now I want to convert those marks to grades. So the A, B, C, and so on. So what I'm going to do is that I'm going to go through, so I'll say, okay, for this person, what is the mark? If the mark is 85, okay, it's going to match a certain grade. So I'll print that. If it doesn't, I'll move on to the next. So the cases. So here, let me just go to the ID because the same thing. So grade reports. Okay, so again, we start with our importation. So this tells us we're going to use the scanner class. And then we have 2 integers here, grade and category. So these are just names I've given you, it doesn't matter. So we create our new object again. So this time not input by scanner. Now I'm saying enter a number between 1 and 100. So I'm going to take whatever grade, or I mean, whatever mark has been, the person has scored. And now I take that and assign to grade. Now what we are doing here is that we have another variable called category, in which case we're dividing the grade by 10. And because it's integer, remember integer takes off the decimal places. So the same, if you enter, whether you are entering 89 or well, I'm just using them for example here. Whether you are entering 89 or you are entering 85, 84 or 81, all these are going to end up as 8 in the category because it's going to divide by 10. So you realize that you're dividing by 10. And then this will be 8.9, 8.4, 8.1. But because it's integer, if it were double, then the decimals will remain. Because it's integer, it's taking them off. It doesn't round up to the highest. Like if you get 89, then we say, oh, that's 90. So let's round it up. No. What's happening is that once you are saying integer, it just cuts them off. So what we're saying is that whatever value you enter, we are going to divide it by 10, in which case, because it's going to be 1 to 100, if we divide by 10, we are going to get discrete numbers, 1, 2, 3, 4, up to 10. Or if you enter 100, that's going to be 10. If you enter 90, that's going to be 9. 91 is still 9. 98 is still 9. No, you come to enter 45, it's 4. You enter 49, it's 4. No, and so once you divide by 10, you now assign that to your category. So it means now category will have a value from 1 to 10. And now we are going to our cases. So we say switch and category. So now we put the value here. So whatever the person has entered. So if you entered 95, there's going to be 9 here. So if you entered 86, there's going to be 8 here. If you entered 42, there's going to be 4 here. And now the cases are listed here. So whichever case that this category matches, then whatever is following that is what will be executed, and then we break. So we have case 10, case 9, case 8, case 7, and so on. Okay, it ends at 7, and there's default. Of course, you can come back, you can go down to 6, and so on. So maybe I can say, let me copy this. So come down, case 6. So case 6 is what, C. Okay, so grade C. So I'm going to, okay, I'm just going to be say below average. Okay, below average. Okay, so whatever the person has entered, I'm now going to be matching with the cases. So whatever the case is, so, and then there's a default. So the default now means your grade doesn't match all of this. And so I will now print out what the default is. With the default, we don't add the break again, because the default is always at the end. So even if it is 100 and you go through all of them, and then none of the cases is matching, then you execute the default at the end. So if I run this, it's going to enter a grade between 1 and 100. So if I enter, let's say 77, what it's going to do is that it's going to take 77, divide by 10. That will be 7.7. But of course, it's assigning it to category, is going to be 7. And now we say switch. And so there will be 7 here. And it's now going to start matching. It's not 10, it's not 9, it's not 8, and it's 7. So I'll now print out B, average, or average grade, and then I end it. So I say break. So it breaks and it ends the program. So if I enter this, that's what it will say. The grade is B. So depending on what you enter, so now you can be entering the student grade. Okay, John got, of course, 100. John got 100. And so we say that is A+, perfect score, or excellent. We come to another person, maybe Moses got 55. Or we say, well, that's not a passing grade, because here it ended at 6. Once 55 means you are having 5 in the category. It doesn't match all this. Another person comes, maybe Amma gets 72%. And so you say, okay, that grade is B, average, and so on, because 72 matches this case. So the switch is also another kind of selection statement that makes it easy for you to just have several cases, and then you can match, whatever is in, whatever is in there, and then you can execute what you want to execute. Again, of course, you can see that it's limiting here, because the moment you enter something above 100, 125, now what happens? If you divide this by 10, you're going to get 12.5. And so this will be 12. 12 is above, well, not above, it's not going to match all these. And so you are going to say, yeah, somebody is, and it's up. Is it Samuel? Yeah.
Sir,
yes.
Please, instead of the integer data type, can we use double?
Well, you can use double, but then it means your cases, that will now make your cases a whole lot, because if it's double, now your cases are not good, because here, you see, as a case 10, because it's going to match exactly what is here, what the case is with the category. So if these were double, then the problem will be that you are not likely not going to double. You see, so once it's double, now, okay, so here, switch category. Okay, category grade is this. Grade category is not allowing the, let me see. There's an error here. Cannot switch on a value type double. Oh, okay. Okay, so what it even means is that this works with just integers or whole numbers, because it says you cannot switch on a value of type double. No, so what it means is that because these are discrete things that is going to be going through. Well, you're going to use double now, then if you divide it by 10, then you're going to be getting a whole lot. So you can have 9.1, 9.2, 9.3, you know. So you are going to put in all these as cases, because what's happening is that 9.1 is not the same as 9.2 and so on. But because you make it integer, then it takes off all that and you are left with. In fact, it can also be used for things like, let me see, if you go to the course textbook, you can use it for things like, there's, switch statements, case, there's something here on lottery. Yeah, okay. Yeah, so there's an example here, switch status. I think there was one for, where is it? Value. Oh, but you can look at this. Yeah, so here it's trying to determine the day, and then you can determine whether it's a weekday or there's something called the zodiac signs. It's in Chinese, you know. So here you can see that. So the switch always works with an integer or a number. Look at here. It says switch. I'm not sure what it is up here. Switch modulus 12. So what what are we trying to do here? You got a number, you are dividing by 12, and you want to see what the remainder is. And so you say, if the remainder is 0, so case 0, case 1, case 2, and so on. And so these are just, I think these are Chinese zodiac. Okay, this has nothing to do with us anyway. But so what it means is that the switch doesn't work with decimals, so you need integer. So that always have to be borne in mind. In fact, if it comes to working with decimals, then you have to do something else. In that case, so I was trying to demonstrate. So here, because I've got something that is above the 10.
Thank you.
Yeah, something that is above the 10, it doesn't match any of these. And then it says that grade is not a passing grade, you know, or I can just say that is not applicable, you know, in the sense that, you know, what you've entered is not working here. Of course, again, if you have issues where somebody is typing in, but not so 90, the person says 90. Now, of course, you are going to have issues because we haven't put in anything that will tell the program that if the person doesn't enter an integer, what happens? So in this case, there's something we call throw-in exceptions. We'll come to those ones eventually. Or you use a loop. So the loop will tell you that, no, okay, if the person enters this, tell the person this is not a number or this is not what you expect. And then you go back and start the program again and give the person the opportunity to enter the number again. So that's where the looping comes in. So that's what we'll be doing next. Okay. So to end the selection and the input aspect of the presentation. So what we're saying is that we want the program to be able to take input from a user. Of course, without that, computers are pretty much useless if you can't take input from a user. It's like the typewriter. Even typewriter, you can say is taking input, but you know, you can't take decisions, you can't do anything. So computers are not just to output or print things, but they're supposed to interact with users. And so for now, to get input, now this already tells us that, or we came across the fact that, you know, input into the computer, there are so many ways. So there's the mouse, there's the keyboard, which is the easiest one or the commonest one. And then you also have, you know, microphone and then camera and all those things. All those take input from the user. And remember, whatever input is being taken, it has to be converted to digits or zeros and ones before the computer can work. So when you talk onto your phone, you know, and then another person at the other end is when it was analog phone, of course, it was using the analog waves. But for the digital phones that we use now, when you talk, the voice is taken and then converted. So we have what we call the modem, or modulating and demodulating. So this will take your voice and then break it down into zeros and ones. And the zeros and ones are transmitted over the network. And when it gets to the destination, it's reassembled, and then the information sent to the speaker so that the voice can come and then we would hear. Now, of course, it happens instantly. And that's because computers work at extremely fast speeds. But that's the process. So it goes, and of course, it's not surprising that it took a whole long time for us to be able to develop all these things up to this stage, in the sense that, it's not easy breaking information from analog to digital and then assembling it back to get you back the exact same information. So taking input from the user or the hardware is not an easy thing. It requires a whole lot of things. And so for Java, what we have is that we need an object, or we use an object that has some methods that are written in there. And remember, when we're doing the thing from the beginning, we are saying that the program now interacts with the operating system of the computer. And the operating system works with the hardware. So the hardware, the on and off of your processors and memories and so on, are working with the operating system. And these are now interacting with your program or your application that you've written. And so when you take the input, it's going to go through all that. So this object will take it, and now it's going to convert it into the digits and all those things, and then assign it to a variable that we have already created. So, or we can do that at the same time. Whilst we are declaring the variable, then we can just go ahead and take the input and assign to it. So in this case, we just said that, take some. So we just said that, I have double income. So this is my variable, and I'm saying next double. So I'm going to take a double value. So in that case, you can type 6.5 or whatever. Integer. So my age here is only going to take an integer. If you type 5, of course, that will happen. If you type 5.5, then you're going to get a problem, because this is expecting just an integer. And so all this, and that's why all these have been spelled in there, because if somebody knows how to do one specific thing, you can't ask the person to do something that's described, or that the person has not been trained or assigned to do. So in that case, we have to be very specific as to what type of value we want. Is it a double? Is it a byte? Is it an integer? And so on. And we're saying that before you even create your scanner object, the scanner class is not within your application by default. You need to import it. In fact, if you were going to type this in Notepad, just like the things we are doing here, like when I did the math, so you needed to import the math class, because you are typing in Notepad, because you are using the IDE. The IDE has brought in most of all these. You see that they're all in there, but a whole lot more. Some of them are not even visible now. But the IDE is an entire complex application in itself. So it helps you a lot. But this IDE is a simplified work for programmers. So they already bring in so many things. If you are going to open Notepad and type in your Java application, then you pretty much have to be manually importing everything. So before you can get the math class to work, you have to import it, import the scanner and all these other things. So in fact, when we're doing this by around Java 2, because by then it was still maybe more or less at its infancy, we used to do import java.star star. So these are wildcards. So this one, you are importing everything into your application. Now you can't dare do that. If you try to do this, what's happening is that you are going to bring in everything that you have installed in Java into your computer memory, and try to crash because it's just too much. You can't import, because if you look at your Java application that you installed, I mean, the JDK is more than maybe 10 gig or something. So you can't bring all that into your computer memory. Your memory will not be able to take it. So we only import what we want to use. And so that's where we have the importation of the java.util.scanner. And then by saying that once we take the input from the user, we should be able to take decisions or give conditions. And when it is met, then we do something. If it is not met, then we do the other. And so those conditional statements are the if. So that only works if the thing is true. But then that doesn't give you an alternative. So we say it's a single alternative. If it is not false, nothing happens. So that, of course, is very limiting. Then we have the if and the else. So if it is not true, then do something else. If it is true, do this, else do that. But we also realize that, the if and the else, we can have nesting. So we can have several ifs and else within other ifs and else. But we say we can equally simplify that type of code by using the and then the or operators. But you can even add a third one. So you can do this, and this and that, and that will be, so if you are hungry and there is food and you have money. Now, so all those things have to be true before you can buy the food. Because if you are not hungry, there's no need buying the food. If there's no food, of course, you can't buy. If you don't have money, you can't buy. So there can be more than two, but all of them have to be true. With the or, then only one have to be true, and then the code will run, or whatever follows will work. And then we have the not, which negates or which turns false to true and true to false. And then we have the exclusive or, which is only true if you evaluate the conditions and one is true and one is false. Sometimes it confuses people a bit. So we're saying, okay, we're taking the whole thing. We're going to see whether the whole thing is true, or we're going to assign true or false to the whole thing. And so once the whole thing, one is true and one is false, then the whole thing is true. But if one is true, the other is true, that is false. If one is false, the other is false, that is also false. So we say exclusive. It should be exclusively one is true and one is false. And then the last one we just talked about is the switch and the case. So we switch between cases wherever you find a match in what is in the switch. So the switch has a parenthesis. It doesn't make it a method, again, that people might think. It's just another way of expressing code in Java. So switch, you put the case in, you put the whatever value you want, and we just notice that it works with integers. Whatever value you want to have inside, and then you can have the various cases. Wherever the case matches, you execute, and then you break. If it doesn't match, then of course you go on to the default, whatever is written in the default. Okay, so that brings us to the end of this input and selection presentation. Yeah, so any comment or question? Yeah, so let me stop the recording and then